Good morning. This is the notes for Math 112 for Tuesday, September the 12th. We're going to start off with going through our math workshop. I know that I posted you need to complete numbers 1 through 8 on Math Workshop Week 6 and numbers 1 through 8 on Math Workshop Week 7. Today what I'm going to do is go through Math Workshop Week number 6, numbers 1 through 8, so you can check your answers. Please, though, finish Math Workshop numbers 1 through 8 in Week 7 also, because this prepares for our big assessment coming up on Tuesday, September the 19th, on trig expressions. So let's go through some of this. So on this first one we have sine of 300. Sine of 300, that is in quadrant 4. Reference angle, to find my reference angle, I say 360 minus 300, which is 60 degrees. My ordered pair associated with 60 degrees is 1/2 square root of 3 over 2. So this is in quadrant 4. My x value is positive. My y is negative. I want the sign. That is my y value. So my answer is negative square root of 3 over 2. Number 2, secant of 225. Secant of 225. That is in quadrant 3. Find the reference angle. I say 225 minus 180. That is 45 degrees. Ordered pair associated with that reference angle, square root of 2 over square root of 2. Means square root of 2 over 2 and square root of 2 over 2. It's in quadrant 3, so they're both negative. You want the secant, that is the reciprocal of the cosine value, which is x. I'm going to flip this, rationalize my denominator, and that leaves me negative square root of 2 as my value. Okay. Number 3, tangent of 16 pi over 3. I'm going to change this to mixed number to help me out here. 3 goes to 16, 5 and 1/3. 5 and 1/3. So, if we're looking here, we went around the unit circle one time. That's 2 pi. Went again, that's 4 pi. Went one more time, that's 5 pi. I'm right here at the 180 degree mark. So I need 1/3 more. That will be in quadrant 3. Reference angle, pi over 3. Ordered pair associated with pi over 3 is 1/2 square root of 3 over 2. This is quadrant 3. They're both negative. You want the tangent. Tangent is defined as y divided by x. So I got negative square root of 3 over 2 divided by negative 1/2. You know negative divided by negative is going to be a positive. That gives me square root of 3. Alright, number 4. Cosine of 450. I want to find an angle that is coterminal with 450 that lies between 0 and 360. So I'm going to say 450 minus 360. That gives me 90. So I'm really finding the cosine of 90 degrees. Well, that's one of your major points. So 0, 1 is the ordered pair. I want the cosine. That is your x value. So 0 is my answer. Number 5. The cosine of 9 pi over 4. 4 goes into 9 2 times, 2 and 1/4. So if I have my visual here, I went around it one time, that's 2, I need 1/4 more, that is in quadrant 1. My reference angle is pi over 4, that is square root of 2 over 2, square root of 2 over 2. I want the cosine, that is my x value, so square root of 2 over 2 is my answer. Number 6, I got a sine of negative 300. I'm going to change that to a positive angle by adding 360 to it. So that's going to give me really sine of 60 degrees is what I'm working with. That's in quadrant 1. My reference angle is 1/2 square root of 3 over 2. It's in quadrant 1. They're both positive. I want the sign. That is your y value. If you have any questions with this, I will answer it on Wednesday. Number 7, the tangent of 29 pi over 6. 6 goes into 29 4 times with 5 left over. So I got 4 and 5, 6. I went around one time, that's 2. Went around again, that's 4. I need 5, 6 more. That's going to mean quadrant 2. Reference angle is pi over 6. Ordered pair associated with that is square root of 3 over 2 and 1/2. Quadrant 2, your x is negative. Now, how do I know it was quadrant 2? Went around it one time, that's 2. Went around the other, that's 2 more, that's 4. I need 5, 6 more. It's not quite another whole, so it's either in quadrant 1, 2, but it's almost another whole because 5, 6 is almost 6 over 6, so that's quadrant 2. I want the tangent, that is y divided by x. Rationalize. I'm left with negative square root of 3 over 3 as my answer. $240, that is in quadrant 3. 240 minus 180 is 60. Ordered pair associated, that's 1/2. Common square root of 3 over 2. They're both in quadrant 3. They're negative. You want the cosine, that's your x value, negative 1/2. Alright, that's our math workshop. Like I said, please complete week 7. We're going to go over that on Wednesday. Okay, the goal today is we're not going to learn anything new today. What we're going to do is do 2 problems to review, and then we're going to go over our piecewise. And just making sure that you understand that, okay? Alright, so the first thing, let's review our learning targets. The first learning target that you're responsible for is I can determine the average rate of change of a function. I can determine AROC. Remember, the formula for AROC is x sub 2 minus x sub 1. Come above it, f of x sub 2 minus f of x sub 1. That's just reviewing that formula. You need to be able to graph and identify all parent functions. Please review those if you have forgotten those already. Next learning target, graph transformations of functions. Okay, we're going to do 2 examples here. Just remember how to do this. Okay. The parent function of this particular function . Alright, parent function is cubic. Now let's describe the description of what we're going to do, because on your assessment you're going to have to be able to describe and graph it. Work from inside out. This plus 2 means I'm going to move it left 2 units. The 2 is on the outside. It involves multiplication. It is what you see. It's going to be stretch by a factor of 2 vertically. This negative means I'm going to reflect about x-axis. And then this plus 3 on the outside means move up 3 units. Now you say, Mr. Hester, when I make my table, I'm just going to multiply by negative 2. can I just put stretch by a factor of -2? No. In your description, you need to put that makes reflection, so I know that you know what that means. Now, let's graph the parent function. Got the parent function. Let's make a table. We need to make a table because we have this value, this -2 right there. All right. This +2 tells me I'm going to move it left 2, so I'm going to add -2 to my x values. Now, this negative does mean reflect, but I'm going to multiply. Since this is stretched by a factor of 2 vertically, I will multiply my y values by this. And I'm going to go on and take care of the reflection and stretching by multiplying the y values by -2. This +3 means I'm going to move the function up 3 units. So that deals with my y. I'm going to leave my x's alone. And those are the points I would graph for this particular function. And that's my new function. Okay, let's look at another one. F of x equals 1/2 x minus 1 squared minus 4. The parent is quadratic. Description. Move right 1 unit, because you see a -1 when it's inside you. It's opposite of what you think. Instead of moving left, you're moving right 1. This 1/2 is on the outside. It's either stretch or shrink. This is on the outside. It's what you think. It's going to be shrink by a factor of 1/2 vertically. It's very important you put that word vertically, because that means it's affecting the y-axis. And then move down 4 units. This is on the outside. Okay. I'm going to graph the parent function. Alright, it is quadratic. Okay. Now, I'm going to make a table since there was a value here. Okay, that moves right 1, so I'm going to add 1 to the x. This is shrink by a factor of 1/2. I'm going to multiply my y's by 1/2. And this minus 4 means I'm going to add -4 to my y's. Leave my x's alone. So -2 and -4 gives me -2. 1/2 and -4 gives me -3.5. 0, -4 gives me -4. -3.5 and -2. And these are the values that I would graph onto my graph paper. Okay, so I'm going to graph those. -1, -2. And that would be my graph. Okay. So today, guys, we're going to continue our learning target from last video. I can graph piecewise functions. So write this in your notebook. I can graph piecewise functions. Learning target. Alright. First I'm going to go over the homework from the previous video assignment. And it was page 59 in your notebook. Numbers 1, 4, 7, and 10. I'm going to do those 4, and I'm going to do 2 more examples, and that's going to wrap this lesson up on piecewise. Alright. So number 1, we have f of x equals x minus 4 if x is less than 2, 1 if x is greater than or equal to 2. Okay? I know in your notebook that you have a place to graph this. I'm just doing it on a piece of graph paper so you can see it better. This is number 1 off page 59. This was your assignment. Alright, so let's look at the 2 lines we're going to originally graph here. Y equals x minus 4 and y equals 1. Now this first one, this is a linear function. You should be able to identify that by now, and you can use slope and y-intercept to graph that. Okay, take a pencil. Y-intercept's -4. 1, 2, 3, 4. My y-intercept. Go up 1 over 1. Up 1 over 1. Up 1 over 1. Up 1 over 1. Make sure you get a healthy line. Then y equals 1, you would just go to the y-axis where it's 1 and draw a horizontal line. Okay. Now, let's look at this right here. Something's going on at 2. So I'm going to put a mark at x equals 2. That's where it's getting on one piece and getting off that function and jumping onto another function. Remember, piecewise functions have jump discontinuity. It jumps from piece to piece. So on this first piece, it wants to stay on it for all values of x less than 2. So if I go to 2, my x values that are less than 2 are this way. So I'm going to go up to where I hit this function, open dot, and for all x values less than 2, that is this. So it's going to be this part of the function. Okay? I don't need this part over here, so I'm going to erase it. Now I'm going to go to x equals 2, go down to where I hit the other function, which is right here. It is greater than or equal to, so I will put a closed dot. It says greater than or equal to 2. All x values greater than or equal to, that is this way. That is this way. And this part of the function is associated with this part of the graph. So I'm going to erase this part. So your piecewise looks like that. Okay. Let's look at our domain and range. Our domain, start from the left. It's an arrow, so it means it keeps going. Even though there's something going on right here, the jump is open here but closed here. It cancels out. So your domain will be all real numbers. Please make sure you put in your domain and range. Okay, range, start at the bottom. It hits the y graph, the y-axis, at -2. And it's a closed dot, -2. Keep going up. It's hitting the graph. Even though it's open over here, it's closed over here. The arrow keeps going, so it's -2 to infinity. All right, number 4. Looking at my two functions, I'm going to graph y equals x minus 1 and y equals -1. Okay? They're both linear. I'm going to go to -1, my y-intercept. Slope is positive. Up 1 over 1. Up 1 over 1. Make sure you get enough points to be a healthy line. Okay? Then y equals -1. Go to y-axis where it's -1 and draw a horizontal line. Now, something's going on at 3. So I'm going to go to 3 on my x-axis. 1, 2, 3. Okay, stop it right there. Now, this first function, x minus 1, I stay on it for all x values less than or equal to 3. So less than or equal to 3 is to the left, to the left, to the left. So what part of this graph is to the left of this? It would be, I'm going to go straight up. That's a closed dot because it's got or equal to. And I will do this part right here because that part covers the span of x values that's less than or equal to 3. And I will erase this top part. Go back to x equals 3. Go down till you hit the other one. That will be an open dot because it's just greater than. Going this way for all x values greater than 3. Erase the other part of the line. Domain. Start from the left. The arrow keeps going on the end. Even though that's here, that cancels that out. So your domain is all real numbers. Range. Start from the bottom. It keeps going. Even though it's open here, there's a closed part over here. It goes up to 2 on the y-axis. So it's -infinity to 2 bracket because that's a closed dot. Take a moment to look at that. All right, let's look at 7 and 10. That involves 3 pieces. Okay, so we got three functions here. We got y equals x, y equals 2, and y equals negative 2x plus 2. So I'm going to graph all three of those. Okay. Y equals x, you should be able to identify that as the identity function. Slope is 1, y-intercept is 0. Y equals 2, you go to the y-axis of 2 and draw a horizontal line. And then y equals negative 2x plus 2. Y-intercept is 2. Slope is negative. Down 2 over 1. Down 2 over 1. Down 2 over 1. Down 2 over 1. Backwards. Oh, messed up there. Sorry. Okay. So, excuse me. So this first graph, you're looking at negative 3. So I'm going to go negative 3. 1, 2, 3. Something's going on there. Okay. It's this y equals x graph first. Go to there, go down till you hit it. That is an open dot. It says for all x values less than negative 3. Well, that would be this way. Well, this is the part of the graph that spans that area. So, I would erase that part. Now, the next part, the second piece, the y equals 2, spans between the areas of x equals negative 3 and x equals 1. So I go up to it, I hit it, that would be a closed dot. Go to 1 on the x, from that, go up, I hit it, that would be an open dot. And it's the area between this, so I would just have this area right here. So I would erase this, and I would erase this. Now this last part, go to 1, go down where you hit it, right here. That would be a closed dot. And so for all x values greater than or equal to 1, that is this way. The part of the function that spans that way is this. And that would be my piecewise function for this particular example. Now, let's talk about domain range. This could be tricky here, but it's not hard. Let's look. Domain. Remember, the arrows keep going here and here. From left to right, I would hit it. This and this cancel each other out. That cancels that out. That cancels out. It keeps going. So your domain will be all real numbers. Range. Start from the bottom. The arrow, so it's going to negative infinity. Even though it's open, it cancels it out over here. And it goes up to negative 2. Now watch this. There's nothing in between here to here. So you have to put a break in your range. And if you look, the range is on length. What value up here? 2. So this will be one where you just have a number in bracket. So from negative infinity, this over here cancels that out. To negative 2. Union, there's nothing here, so you have to break it up to just the y value of 2. Okay? Pause if you need to and look back over this. Okay, our last homework problem is number 10. We have f of x equals negative 3, if x is less than or equal to negative 4, x if negative 4 is less than or equal to x less than 2, negative x plus 6 if x is greater than or equal to 2. Alright, we got three functions here. We got y equals negative 3, y equals x, and y equals negative x plus 6. Okay, y equals negative 3. That would be at negative 3 on the y-axis, horizontal line. Okay, y equals x, that's the identity function again. Negative x plus 6, my y-intercept 6, 1, 2, 3, 4, 5, 6. Slope negative 1, down 1 over 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 1. Go backwards. Alright, so the first one, we're looking at negative 4 on the x. 1, 2, 3, 4. So something's going on here. We want this to stay on this piece of the function for all x values less than or equal to negative 4. So I'll go down from it until I hit it. That will be a closed dot. For all x values less than or equal to negative 4, that is this way. So I would use this part and erase this part of the function over here. Next, the y equals x, this part. At negative 4, I'll go down to where I hit it, open dot. And then the other part is x equals 2, so I'll go over to 2, to where I hit it, which is here. That would be open. I want the area between negative 4 and 2, so that would just be this right here. I would erase the other parts. Then this last function, negative x plus 6, go up from 2. Close dot. And that would be my piecewise function. Now domain and range. The arrow keeps going, so negative infinity, that cancels that out. That cancels that out. And it keeps going, so domain is all real numbers. Range. Okay, let's look at this. Range is tricky. There's no, where this arrow keeps going, this arrow keeps going and going. This arrow keeps going, so it will be from negative infinity. That almost tricked us. So since that keeps going and going and going, that will cancel this out. That will cancel that out, so it's up to 1, 2, 3, 4 is as tall as it gets. So that will be my range. Take a moment to pause the video if you need to look at it. Okay, on the same page as your homework was, page 59, I'm going to do two more examples with you, number 6 and number 9. And that's going to be the end of this lesson, number 6 and 9. Your homework assignments are going to come off the same page again. We're just practicing this. So I want to look at number 6 on your page 59. F of x equals x squared if x is less than or equal to 1, and 2x plus 1 if x is greater than 1. Okay? Alright, the two functions we're graphing is y equals x squared and y equals 2x plus 1. Now, what type of function is this? I hope you said quadratic. We cannot use slope and y-intercept on that. We just graph the parent function. Graph the parent function. Just like we've been doing in previous lessons. Then y equals 2x plus 1. That is linear. I can use slope and y-intercept. So, y-intercept's 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Backwards, down 2 over 1, down 2 over 1, down 2 over 1. Alright. Now, what's going on? We have discontinuity at 1, so I'm going to go to x equals 1. We're going to stay on x squared for all x values less than or equal to negative 1. That means it's this way. This way. So I go up to it where I hit it, which would be a closed dot, or because the or equal to. And I want the part of the function that expands the area where the x values are less than or equal to 1. And that would be this way. So I would erase this part of the graph right here. Okay, go up from x1 till you hit the other one, which is here. That would be an open dot because it's just greater than. You want it for x values greater than 1, which would be over here. This part of the graph spans this area. So I would just keep that part. Now my domain. Pay attention. This keeps going. That keeps going. So my domain, if I started from left, I would eventually hit it. All real numbers. This cancels that out. That's why you'd have to put a break. Your range, start from the bottom. It would be 0. Bracket because it's closed. It's still hitting. Even though it's open, it hits it over here. So 0 to infinity. Take a moment if you need to pause to look at that problem. Okay. Let's look at number 9. Last example. So I see you on Wednesday. Wednesday we will briefly go over your homework from tonight and then move on into the next learning target. Remember, we're lifelong learners. Alright. So let's look at these three functions. We have y equals 8, y equals 2x, y equals negative 4 minus x. I'm going to draw a pretty big graph here. For you to see it. Y equals 8. I go to 8 on my y-axis. 1, 2, 3, 4, 5, 6, 7, 8. Y equals 2x. That is linear. So y-intercept is 0, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Enough points to have a healthy line. Then negative 4 minus x, that would be 1, 2, 3, 4. Down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Okay. So this first one is at -1. I go -1. I'm going to go up to my y equals 8 graph right here. That would be a closed dot because it's less than or equal to. Less than or equal to. Okay, the part of the function that spans the x values less than -1 is this way. So I'm going to keep this part of the graph and erase this other part to the right. Okay. Now y equals 2x. This is this graph here. I'm going to go at -1 to down to where I hit it. That would be an open dot. Then I go over to 4. 1, 2, 3, 4 is here. Go up to where I hit it. That would be an open dot. I want the area that's between -1 and 4. That would be this area right here. I would erase this. Why did I keep that part? Because that part is the part that spans from x equals -1 to x equals 4. Then I'm going to go to x equals 4, go down until I hit this other one. That will be a closed dot, and it was for all x values greater than or equal to 4. That is this way. So I'll erase this part. Check your dots. Closed dot, open, closed. Now, let's talk about the domain and range on this one. Notice the arrows keep going here and here. So your domain would be all real numbers. Now your range, you're going to think about it. This keeps going, so if I'm down here at the bottom, it's -infinity. But when I get from here to here, there's nothing in between the graph in this area, so you do have to make a break here. Okay, that's 1, 2, 3, 4, 5, 6, 7, 8. So -infinity to -8, bracket, because it's closed. Union, now pick up here. Parentheses, -2. It hits the y, That cancels that out, so it's 1, 2, 3, 4, 5, 6, 7, 8. So -2 to 8, bracket, would be my range. Okay, so your assignment for Tuesday. Okay. Is on the same page, page 59 in notebook. Numbers 2, 5, 8, and 11. You have 4 problems I'd like you to do. 2, 5, 8, and 11. We're going to go over those on Wednesday. Now, that was Tuesday. Just to recap what you had on Monday. To make sure. Monday's assignment was to complete numbers 1 through 8 on week 6 and 7 math workshop. Finish, checkpoint on transformation. And it was page 59, numbers 1, 4, 7, and 10. So here's Tuesdays, here's Mondays. I'm going to be checking for all that on Wednesday. Okay? If you have any questions, please email me or text me through Remind, and I will do my best to answer them. I'm kind of liking these videos where you can stop and replay and understand. So this is going to be something new in the future. All right, y'all have a great, safe day, safe 2 days. Please be careful, and please make sure you watch these videos.